two good old-fashioned warm-up problems in preparation for Friday's test that we can then start with. It's going to be on it, so might as well start, you know. So on this first one, this first fraction, 3x y to the fourth all over 9x cubed y squared. That one doesn't change at all. The other one, however, changes to 9x to the fourth all over y to the sixth when I square both top and bottom. So then this 9 will cancel out that 9 because they're on top and they're on the bottom. This y to the fourth will cancel out 4 of them down here, but that leaves me with 2 left over. This x cubed will cancel out this x to the fourth, but it'll still leave me with 1 up top. And I think that's all that can be simplified out of there. So that leaves me with 3x squared on the top and y to the fourth on the bottom. Yes? Over here on this one, we're going to save the x plus 3 to multiply in a second. But so what this one, these two multiplied together get me 6x squared plus 2x minus 3x is plus x. And then minus 2. Okay. So then we can multiply in the x, and then that would get me 6x cubed plus x squared minus 2x. And then I multiply in the 3, and that's going to get me 18x squared plus 3x minus 6. So when it's all said and done, I get 6x cubed plus 19x squared plus x minus 6. Yes? Okay. So today what I'd like to do is I'd kind of like to wrap everything all up in a nice tidy little bow. Okay? Alright, so I'm going to give you a problem. In this case it's going to be negative x cubed plus 3x minus 2. And I want you to do everything that you can with that problem from this chapter. First off, I want you to list off the possible zeros. Then, I want you to find it in factored form. Then, I want you to find the actual zeros. Then, I want you to sketch the graph from all the way back in section 2. And then, I want you to write the end behavior of that function in the proper form. Okay? All right? I think we can do that. I'll give you 7 minutes. Shouldn't take more than that. This was a good starter. Need more time? Yeah? List of possible zeros. What's my list? 1 and 2? Plus or minus with both of them? Any other ones? Okay. Love it. Of those 4, did we find 1? What you got? 2? So if I put 2 into negative 1, 0, 3, negative 2. Uh-oh. Uh-oh. No, so 2 doesn't work? Okay, so we're not going with 2 then. Positive 1. Okay, we'll go with positive 1. Negative 1. Negative 1. Negative 1. Negative 1. 2. 2. 0. Okay, so that one is a 0. So f of x now becomes x minus 1 times negative x squared minus x plus 2. Yes? Can I factor anything out of the orange? Yes? No? Maybe? What can I factor out? How about negative 1? Yes? Red. Can red be factored then? Kyle, what are you thinking? An x plus 2? Yep. So altogether, this factored form is going to be negative 1 times x minus 1 times x minus 1 times x plus 2. That is a factored form. Now we can find the zeros, set our factors equal to 0. That's the one we got up above. That's our other one. Don't have to do the other x minus 1 because we did it once already, right? Okay. So all of my zeros then are there. Whoa, whoa. Tap the brakes. Okay. So then put that up there a little bit. And then our function was, our original function was f of x equals negative x cubed plus 3x minus 2. So based off of the 2 zeros that we have, what are some key points that this graph would go through for my sketch? What? Negative 2 is just a number, not a point. What do you got? What do you got? Honestly, I didn't hear you. The fan's going. So it's got a y-intercept of negative 2? Does it have, which one? It does have a y-intercept of -2. Yeah, it does. How do we get a y-intercept again? How do I know that it goes through the point 0, comma, -2? So I find f of 0, right? So if I find f of 0, this term goes away, that term goes away, leaves me with -2. So it does go through the point 0, comma, -2. Nikki, what were you actually, though, trying to tell me? Not 0, comma, -2, but -2, comma, 0, because it's got a 0 at -2. Oops, I got to put the old pen back on. Is that a through and through, or is that a kiss? At -2. That's a through and through. That's a crossover one. Okay? What about at 1, comma, 0? That's a kiss because the 1 was a double. Okay? So based upon that, brakes, get off of there and get back to here. So based upon that, that would tell me then that this one goes like this. Because we have an odd degree, they are going in opposite directions. Because we have a negative lead coefficient, it's going down and to the right and up and to the left. So my end behavior in the proper form would be what? As x goes to positive infinity, f of x goes to negative infinity. That's one of them. Okay. Not written like that, you will get it marked wrong on Friday. That is how you write end behavior. Okay. I've seen a lot of different variations of that. None of them have been correct. Okay. Questions on that one? Awesome sauce. Same thing, different problem. Possible zeros. Plus or minus 1, 2, and 4. Yep. Yep. Did we find any of those 6 that worked? -2, you say, works? Okay. So if I put in -2 into 1, 0, -3, 0, -4, that's -2, so that's -2, that's 4, that's 1, that's -2, that's -2, that's 4, that's 0, that works. Yes. Do we find another one that worked? +2? One, 2, 0, 0, 1, 2, 0. Love it. So f of x actually I can go right to it. f of x is going to be x plus 2, that's my blue one, x minus 2, that's my green one, x squared plus 1 is what's left over, and that's not factorable. Okay? So then all my zeros would be x plus 2 equals 0, so that's x equals negative 2. X minus 2 equals 0, so that's going to be x equals positive 2. X squared plus 1 equals 0, so x squared is going to equal negative 1. So x is going to equal plus or minus I there. So all of my zeros are plus and minus 2 and plus and minus I. Sketch of the graph. This was again f of x equal x to the 4th. Is it minus 3x squared? Nope, sorry, minus 4. That tells me that I'm going to have a y-intercept of negative 4. Goes through positive 2, goes through negative 2, okay? And then actually it goes down to there, and it goes down to there, and it comes up through here, down, comes up, makes a W. Oops, that should have been right there. Just went over a little more. Something quite similar to that. End behavior. Is there. Questions? Awesome sauce. Okay. So, 1. I'm giving you a worksheet today. That worksheet will be due tomorrow. I'm also giving you the review assignment. That will be due Friday. I'm also expecting you to turn in all of your homework, or your homework from Monday, today, to the turn-in folder. Okay? And also, all of your chapter 3, or your unit 3, excuse me, corrections should be turned in by Friday. Okay? So while you guys are handing stuff in, actually, when you come to pick up or turn in your homework, you can pick up the worksheet.